Hey, today we're going to look at a skills integration challenge from the Cisco Networking Academy. And although I'm not going to do this assignment end to end, my purpose here today is to focus on one of the aspects of the assignment, which is developing an addressing scheme for multiple subnets. So often I come across students who are great with configurations of the routers and the switches, and they're given pretty explicit instructions, and they can do a great job. But when they have one of these skills assignments, which require a little bit of upfront planning, they get a little bit stumped. So that's what I want to spend some time on today, is that planning phase and how to handle it. So in this particular skills assessment or challenge, we've got a router called Central, an ISP cluster, and a web server, and they're all pre-configured. And the student is tasked with creating a new IPv4 addressing scheme that's going to accommodate 4 separate subnets. There's going to be one for the staff, sales, and IT, and we also need a guest subnet, which is going to be added in the future to accommodate 25 additional hosts. And then after that addressing is developed, then you'll actually need to implement the addressing scheme through router, switch, and NIC interface configurations, and add some additional security center settings to the devices. I'm going to focus again today on that prep stage. So inside the packet tracer, we have the challenge, as you can see, laid out for us. But to make things a little bit more organized, I've copied all those things into a Word document. And you can see I have the same chart, the verbiage. I've taken a screen snippet of the topology and laid it right in here. And then here's where I'm going to add some additional things for me to noodle out that addressing scheme. Okay, so one of the first things that we need to do is decide where these subnets, the size of each subnet, and which addresses we want to use, and how we want to, borrow some addressing bits to accommodate these different size subnets. So one of the things I want to remind you about that you've learned in your studies is that little calculation to find out, based on the number of bits being used, how many hosts that number of bits will accommodate. And it's 2 raised to the number of bit positions power, and then you subtract 2. Why are you subtracting 2? Because you need 1 address for the network itself, and you need 1 address for the broadcast. Okay. So 2 to the 7 minus 2 will give me room for 126 hosts. 2 to the 6 minus 2 for 62 hosts. 5 bits will give me room for 30 hosts. 4 bits for 14. And you can work your way down from there, but this will give us a platform necessary to solve this particular problem, which is asking us to accommodate 100, 50, 25, and then 25 more for the guest unit allocation. So we are given a starting allocation of a /24 network of 192.168.0.0. /24 means that 24-bit positions are representing the network, which means the final 8-bit positions are representing our hosts or end devices. So I've just laid out a little table here to help us organize that. And so 192.168.0 and 8 bits worth of zeros will be that final 0 in a dotted decimal format. So you can see here what I've done. I've just kept the first 3 octets in the dotted decimal format, and I've carved out that last octet with the bit positions. So we can see 100 hosts. The 6 bits won't do it for us, right? So we have to go up to 7. So let's put that imaginary barrier line there at the 7th bit position, and we can see that we can start counting at 1 all the way up until we fill up every bit position with 1s, which would then flip us over to a 1 in that 8th bit position, which would be a new subnet, right? So in this case, we are using a /25 network, and that 192.168.0.0 network with a /25 will be a subnet that can accommodate 100 hosts. The starting address, the starting usable device address is 192.168.0.1 and /25. So /25 is the same thing as an address mask of 255, 255, 255, and 128, right? So I think I want to just make this chart a little bit wider if I can. Make that table there so that we can have everything on the same line. Okay. So that will be the starting address and the address mask available for this first subnet. I'm just so happen to want to call that out up here in my drawing, and I'll just use that first address for the router gigabit 0/0 interface, because that's the interface that's going to lead to the subnet that needs to accommodate 100 hosts. When you work this out, you may want to print out this document, scratch things in pencil or pen, your favorite writing instrument, so that when you go back to fill out the chart, you have a visual. Okay. Next, we need to look at sales, and sales, we'll mark here in red, is going to need to be able to address 50 hosts. We could see that 6 bits will do that for us. We might put another demarcation line here and see that we can have a network that might be named 192.168.0 and 128, okay? And that baby is going to be a /26. Okay. And that, if we want to look at the address mask for that, then we'll be looking at 2 1s, right? Because that is the area that we are now being borrowed, okay? So that would be, what, 128 plus 64, which would give us 192. So an address whose name is, or a network whose name is 192.168.0.128 in a /26 world, so to speak, can also be called a 192.168.0.128 network with an address mask of 255.255.255.192. And we will be able to represent 62 host devices, which is more than enough to accommodate the 50 that we have been asked to accommodate. And we can count 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 2, all the way until we fill up to all ones. And then what's going to happen, we are going to flip over to the next subnet. Okay. Okay. And that next subnet will then be a /27 network. And that would be 192.168.0.224 would be the network address in a /27. Okay. And /27 means 27 bits represent the network, and the final 5 represent the host. So we can now, in that world, accommodate 30 hosts, which is enough to accommodate the 25 hosts that we need for the IT department. Okay. And we also need an additional 25 for the upcoming guest network that will also work with the /27, which, if we want to write that as a subnet mask, that is going to be 255.255.255 dot what? There's going to be 3 ones if it's a /27. Okay. So that will be 224. Right? 128 plus 64 plus 32. All right, so this is enough information to get us going. And now we can take this information and fill some things in up on our chart. So 192.168.0.1 is a great address to use for the G0/0 interface with the subnet mask of 255.255.255.128. Where did I get that from? I got it from here. Okay. So it's the first usable address in this /25 network that we learned was 7 bits and can accommodate 126 hosts. So we're going to use that for the R1 router G00 interface, which goes to the staff subnet. And then we'll use 192.168.0.129 with a 222.55.192 for the subnet mask. For the G01 interface, which is the one that is going over here to sales with 50 hosts. Why 192 and why 129? Well, let's remind ourselves that we are now in this subnet, a network of 192.168.0.128. I'm just choosing the first usable address in that network. So add 1 to the network number and the same subnet mask. So here we have the first usable address and the subnet mask. And then for G0/2, we're going to have 192.168.0.193 with mask of 224. And again, you can ask yourself why. Well, that G02 interface is this one. It's going out to the IT subnet with 25 hosts. 25 hosts can be accommodated with 5 bits. So we are looking at the /27 network here. And I'm going to use the first usable address. I think I made a mistake. Yeah, this should be 192. Yeah, that's the 192 network. The rest of it is okay. So I want to use the first usable address in that network, which will be 193, and that subnet mask. And in actuality, we'll have 192.168.0, and we will have a network 224 that's also /27. That is what we'll use for the guest, the extra. Okay. Okay. So we have a good bit filled out here. Switch 1, the VLAN 1, it's going to be in the staff network. So I just added 10 to the router address, and I'll use the same mask because it's in that same subnet. For switch 2, I will use a similar philosophy. I'm going to add 10 and use that as my VLAN address. And same subnet mask. And for switch 3, same idea. If I add 10, that will be 203, and its subnet mask will then be 255.255.255.224. For the network interface cards on the end devices, we just need to find, again, valid addresses in the correct address space. So I just decided to use 192.168.0.126 for the staff PC, and that happens to be in the address space with the 100 hosts. So that is 255.255.255.128 mask, because we only borrowed one bit, moved it from a /24 to a /25 network. And the sales PC, I decided to use 192.168.0 and 190. And that sales PC happens to be in the subnet that's off of the G01 interface. So I will use that matching subnet mask. And IT, I'm going to use the address 192.168.0.222, which is correctly in the address space of the G02 interface of that router. And here we go. We will want to figure out default gateways. And remember that a default gateway for any device is that closest router interface to the device, as if you're reaching out from the device until you touch a router interface. So that staff subnet is going to reach the G0/0 gig 0/0 interface on the router, which happens to be 192.168.0.1. So 192.168.0.1. The sales PC reaches out to 192.168.0.129. And the IT reaches out to 192.168.0.193. Okay. So now the chart is filled in, and you can transpose that information onto the diagram if you would like to do that, and then you are ready to get going. So I have got going. I can go into Enable and show IP interface brief, and you can see that I have the addresses on the gigabit interfaces with the proper masks. The serials were already set up for me. In the switch, we can show the running config. That's another way to see what's configured. And you can see that we have an interface VLAN 1 with the .11 address and the 255.128 mask, and an IP default dash gateway of that router interface in that subnet. Each of the switches has their configuration similarly done. So we can look and enable and show run for the second switch and see that address, mask, and then the second router interface's IP address. The PCs have the IP addresses configured, also the IP version 6 information, which is included in the chart. It's just a matter of transposing. So I hope that this will assist you, not just with this particular exercise, but any exercise in which you have to develop an IP addressing scheme for a network. Thanks and good luck.